Okay, we're going to look at scientific notation. Um, First, before we go into scientific notation, let me try to dispel the idea of moving decimals to the left and to the right if you have things are positives. Um, Rather than thinking about left or right, I want you to think about larger or smaller. Okay. Any number can be made larger if you move the decimal this way. Any number can be made smaller if you move the decimal to the left. So moving to the right makes a number larger. Moving a decimal to the left makes a number smaller. So think of large and small instead of left and right. Because left and right kind of changes from time to time, depending on what you're doing. But larger and smaller remain the same when you're doing scientific notation. So let's look at that. So positive exponents means that you're going to make the number larger. Negative exponents mean that we're going to make the number smaller. Okay. Since we have a positive 2, we want to make this number larger. So we're going to take 1.5 and make it larger. It makes it larger to 15. One more move makes it larger to 150. And there's 150. And remember, all whole numbers actually have an invisible decimal behind them. Most times we don't write it, but the decimal does exist right here. So we can always produce it by putting 0.0. Okay. Here, the negative means we want to make this smaller. So we take 1.5, and to make this smaller, we move the decimal here. That makes it smaller. That makes it 0.15. Let's make it even smaller. Put 0 here. Now it's 0.015. And make it even smaller here. Put 3 moves here. And it ends up being 0.0015. And you can see that the number was made smaller because of the negative exponent. Number 3. Positive 1 means we want to make this number larger. So to make this number larger, we move it this way, and it becomes a 90.05. And now it's larger. Okay. Negative 1 means we want to make the original number here smaller. Okay. So to make this smaller here, I'm going to move in this direction. It's become a 0.9005. Okay, so once again, we want to represent these as scientific notation. So the question is, are you representing a large number or are you representing a small number? If you're representing a large number, your exponent is going to be positive. If you're representing a small number, your exponent is going to be negative. So this right here is a large number. Large in comparison if I put the decimal here. So if the 1 had a decimal, so let's just put a decimal right there. And those zeros behind the decimal we really don't need. Since the original is a large number, and it takes, let's see here, let's go take this numbers here. There's an invisible decimal there. So 1, 2, 3, 4 moves, and now it's 1.35. We don't need those zeros behind the decimal. But since this is representing a large number, we put a 1, 2, 3, 4, positive 4 here. Again, 4 means that this is a large number originally. Okay, so let's take this number here. Okay, And this is a small number. We're going to move the decimal over behind the 1 right there. So it becomes a 1.35. We don't need these last 2 zeros. And that was 2 moves. So this times 10 to the second power. And this is representing a small number, smaller than the scientific notation number. So it's going to be a negative. So -2 says we're representing a small number. Okay, over here. This is 103,500. Your decimal is right here. I'll put a 0.0 that represent what decimal is. And we want to move that decimal right there. So 1, 2, 3, 4, 5. So this is 1.035. Okay. And furthermore, let's see, main loops. We have 1, 2, 3, 4, 5 loops. So times 10 to the 5th. And this is representing a large number. Okay, so this is going to be a positive 5. So positive 5 lets us know this is a large number. Okay, this one right here. Let's move the decimal behind 1. 1, 2, 3. Okay, so this becomes 1.05 times 10. We have 1, 2, 3 loops, which represents power of 10. 10 to the power of 3. And the original is a small number compared to here. So we're representing a small number with this. This needs to be a negative. Okay, there we go. Okay, these are not scientific notation right now, simply because the decimal is not behind the first number here, 1, 2, 3, 4, 5, 6, 7, 8, or 9, other than 0. So the decimal is not behind the numbers that are other than 0, the first number other than 0. So let's work with this part right here to turn this into our scientific notation, and then we'll work on that last part. So this right here is 900.5. We're going to move it here, so it becomes 9.005. This right here is representing a large number, so this would be times 10. We have 2 loops here, W to the second power. And since the original is a large number, this is a positive 2. Then we bring down our times 10 to the first power. Okay. So now we have this part and this part. These two combined by adding exponents. So this would be 9.005 times 10 to the third power. And that's finished. That's scientific notation now. Okay, once again, we want to turn this into scientific notation. So 900.5. We want to move this twice here. So this becomes 9.005 times 10. And we have 2 loops here, so this will be the second power. And the original was a large number, so we represent with a positive 2. This we bring down times 10 to the negative 1 power. And from here, we're going to combine these 2 exponents. So we get 9.005 times 10 to the first power. When we combine 2 and negative 1, we get a positive 1. Okay, take a look at number 11. Okay, we want to convert this. We want the decimal to go right behind the 1. So let's write this again. We see it's 2 moves there. So this means this is now a 1.5 times 10. And we have two moves here, so that's the second power. And furthermore, the original was a small number. So to say that this is a small number, we're going to use a negative here. So negatives represent the original number is small. Then we'll put the times 10 to the second power right behind it. So we combine these two. So this is going to be 1.5 times 10 to the 0 power. And 10 to the 0 power makes this all 1. So it's really a 1.5. But we wanted a scientific notation, so we write 1.5 times 10 to the 0. Okay, take a look at this next one. Okay, I want to move the decimal here. So this becomes a 1.5 and times 10. We have two loops here, so that means second power right there. And since the original is a small number below, much smaller than the 1.5, then to represent the original, we need a negative here. So negative 2 says that this was a small number. We'll bring down our times 10 to negative 2, so we can combine our times 10 to the negative second power with the other times 10 to the negative second power. We end up with 1.5 times 10 to the negative 4th power. Okay. And this is now scientific notation. Okay, now we're going to multiply terms here. Some of them are in scientific notation, some of them are not. But we want to put the final answer in scientific notation. So what we do here is that we regroup these. And I'm going to multiply the 1.5 times the other 1.5. And then we're going to group the 10s. So this will be 10 to the second power times 10 to the third power. So just regrouping. So first let's multiply these two. Let's don't worry about these two yet. So 1.5 times 1.5 ends up giving us 2.25. And this right here, we'll just make that times 10 to the second power, 10 to the third power. Not really bothering with this. Okay, and make sure this is, okay, this is already in scientific notation, so this is really good. So We can go ahead and combine these two. We get 2.25 times 10 to the fifth power, and we're finished. This is all scientific notation. Rule 14. Again, we're going to group the 0.8s together. And then we'll group the times 10 to the third power times 10 to the negative fourth power. Okay, let's deal with this first. 0.8 times 0.8, that ends up being a 0.64 times 10 to the third power times 10 to the negative fourth power. Okay, now I want to put this into sign, so this will be a 0.64. We'll move this over here, so it becomes a 6.4 times 10. Okay, so that's only one move there, so it's going to be the first power. And the original is a small number, so small numbers have to be represented by a negative exponent. So we bring down our times 10 to the third power and our times 10 to the negative fourth power. Now we can put all our exponents together. Putting together the -1, the 3, and the 4 gives me a -2. So times 10 to the negative second power. And that's it. That's finished. Okay, number 15. Again, we're going to regroup this. So multiply the, actually could be 0.12 times the other 0.12. And then we'll multiply the 10 to the negative second power times 10 to the negative third power. Okay, so let's, yeah. Oh, I think this was a positive, and this was a negative. Okay, all right, so let's multiply these two together and we'll get 144 and 0.0. Okay, there we go. So 0.0144 times 10 to the negative second power times 10 to the negative third power. Okay, so those are that. Okay, let's make this scientific notation. So 0.0144. We're going to move this over twice here. So it becomes a 1.44. Let's do the 16 out the way. Okay. So this is now going to be two moves, so that's going to be times 10 to the second power. And the original was smaller. So this, to represent the small number here, we need a -2. Everything else we'll just bring down. So 10 times 10 to the negative second power and 10 to the negative third power. Then we're going to collect all our powers here. So we're going to get a -7 power. So 1 point, that's it. Okay, and let's do 16 here. Okay, number 16. We have, I'm going to group my, putting some zeros there. They really don't matter if you don't have them right now, but I know people like to see that zero in front. So 0.5 times 0.5, and then here we'll group the times 10 to the 6th power times 10 to the negative third. Okay, let's multiply these two. This is going to be a 25, and then 0, 0, 0. Okay, so there we go. And furthermore, these two right here, we'll just put it as times 10 to the 6th power times 10 to the negative third power. And I want to move this here, so let's rewrite this. And then we'll move it. So 1, 2, 3. It goes right there. So now it's a 2.5. Furthermore, since that's 3 moves, this will be times 10 to the third power, times 10 to the 6th power, and you have your times 10 to the negative third power. So when you combine all these exponents, the -3, the 6, and the -3, you're going to get 10 to the 0 power. So this ends up being 2.5 times 10 to the 0.